So next we have Scott Chapman.
All right. Well, yeah, so I'm Scott Chapman. I work on a variety of things focused on, at the moment anyway, looking at structures in the early universe. So I analyze astronomical data, and I build instrumentation, and I work with theoretical simulations to try and interpret the structures. So what I was trying to portray here in the bottom left is actually a simulation of a massive structure that I discovered a few years ago in the early universe, about 1 billion years after the Big Bang. It was discovered with the South Pole telescope, and what you're seeing is essentially the most colossal merger of galaxies ever witnessed in the universe. 14 galaxies more massive than our own Milky Way, all crashing together in a volume that's no larger than the dark halo of our own Milky Way. So it's a colossal event with more than 10,000 stars per year forming as a result. So this was possible to find because of unique instrumentation, novel instruments on a millimeter wave facility called the South Pole Telescope. But it has other parallels as well. In just under my own name there in the middle, bottom middle, you can see a picture of myself just to illustrate that I actually go places and do things, but I would much rather the grad students made these treks to the Andes these days in Chile and did these kinds of things. So I'm working on a millimeter facility called Polar Bear there, which we commissioned a few years ago. The next telescope I'm really interested in is the CCAT telescope in Chile. It's a model of what will go in Chile for first light in 2022. So Canada is actively involved in this facility, and it's another kind of millimeter telescope that can find structures like this protocluster of galaxies that I'm telling you about on the left. And I am the lead for a 350 micron camera that will go on this telescope, which would be a fantastic opportunity for grad students to start hands-on to build the kind of instruments and cameras that will discover structures in the early universe like this. And I also lead several aspects of this GearMOS instrument that both Alison Mann and Paul Hickson were telling you about. I lead the adaptive optics system that will give us the sharp imaging that we need to see the structures in galaxies, and also the full instrument structure we're trying to build at UBC, which is kind of what you see pictured there in the schematics. Come and talk to me if you have interest.
Thank you, Scott.
Thank you.